Okay guys, as you can see in this first theorem, our formula is the limit of c x approaches a is equal to c.
In this first theorem, kahit gaano kalaki yung value ng approaches, ang sagot is yung C. Example. As you can see in this example, the lim 5 approaches x4, the answer is 5.
So, ang kinukuhanan natin ng limit is already x. The limit of x as x approaches a is just equal to a. Kaya ang gagawin natin, kung saan nag-a-approach yung x, in this case yung a, siya na agad yung sagot natin.
Example. As you can see in this example, lim x approaches to 4. The answer is 4.
Number 3, level up na natin ng konti. We have our constant multiple rule. Kapag meron tayong limit ng isang certain function, f of x, as x approaches a, na ang sagot niya ay L, kapag ka meron tayong k na constant, na minultiply natin dun sa function, as x approaches a, pwede natin ilabas yung value ng constant na k, tapos i-multiply na lang natin siya dun sa sagot ng limit natin ng function as x approaches a. Para mas maintindihan natin, lim 5x x approaches 3, lalabas natin yung 5, tapos ikakopy natin yung lim x, tapos approaches x approaches 3. Pagtapos, ilalagay natin sa baba yung 5, tapos ita-times natin siya sa 3. Ang magiging sagot dyan is 15. The sum and difference rule. So what if meron tayong dalawang limits na pinag-iiwalay naman siya ng addition or subtraction? Suppose we are given with the limit of our function f of x as x approaches a as equal to L, ito yung sagot niya, pero meron pa tayong isa pang function, the limit of g of x as x approaches a is equal to m, ito naman yung sagot. Pwede nating ipag-iwalay kapag ang operation nila is addition or subtraction, separately yung treatment ng limit natin. So, kukuhanin natin yung sagot ng limit ng f of x as x approaches a, which is L, tapos kukuhanin din natin yung limit ng m natin. So, this is addition or subtraction. Let us illustrate that dito sa ating example. We have the limit of 2x plus 4 as x approaches 1. Kung makikita natin, meron tayong 2x tsaka 4. Kaso, pinag-iiwalay sila ng addition. According to our sum and difference rule, pwede natin i-treat yung limit nila separately. Kunin muna natin yung una, si 2x, we have the limit of 2x as x approaches 1, dapat hindi magbabago to, and then dapat consistent tayo kung addition to addition, kung subtraction ay subtraction. Since this is addition plus, iwalay naman natin yung pangalawa, which is 4, the limit of 4 as x approaches 1. Ito, pwede na natin siyang gawin kasi we have a constant 2 na nakamultiply kay x. By constant multiple rule, pwede natin ilabas si 2. So, this is just equal to 2 times the limit. Ano na natira sa loob? We have our x as x approaches 1 plus the limit, this is just constant, of 4 as x approaches 1. Then, ito, by theorem 2, the limit of x, ang titignan lang natin ay kung saan siya nag-approach. So, we have 1. This part is all equal to 1. So, this is equal to 2 times ito is just 1 plus the limit of a constant kahit saan pa ito nag-approach, ang sagot lang natin is our constant, in this case 4. So this is just 4, and then this is equal to 2 times 1 is 2, plus 4, and then 2 plus 4, this is equal to 6. Ito yung sagot ng limit natin using sum and difference rule. The limit of f of x as x approaches a, ang sagot ay L, tapos another function g of x as x approaches a, tapos ang sagot naman ay m. If the operation between our two functions is multiplication by product rule, pwede rin natin ipaghiwala yung treatment ng pagkuha ng limit ng f of x at g of x. Yung sagot niya na L times m.
Doing that, this is the example. Lim of x times 6x minus 2. X approaches to 3. Ang gagawin lang natin is paghiwalayin natin sila, tapos makukuha natin yung sagot is 48. In the theorem number 7, power rule, the the lim of fx to the power x approaches to a is equal to lim fx power x approaches to a. That's the formula.
Limit of a certain function na naka-raise sa certain exponent t as x approaches a, pwede mong ihiwalay, pwede mong ilabas yung treatment ng power. Kuhanin mo muna yung limit nung nasa loob, tapos saka may apply yung power na nandito. So we have our example here, the limit of x cubed as x approaches to. In this case, dahil meron tayong exponent na 3, ang f of x natin is just x, ang gagawin natin, kukuhanin muna natin yung limit nung nasa loob, tapos tong power na to, iiwan natin siya sa labas. So this is just equal to the limit ng ating x as x approaches to, tapos yung power natin na 3, mamaya natin yan iisipin, ilalagay natin siya sa labas. So the limit of x as x approaches to, this is just equal to kung saan nag-a-approach, that is 2. So this is equal to 2, and then this is raised to 3. 2 raised to 3 is 2 times 2 is 4 times 2, that is 8. So this is just equal to 8. So kapag meron tayong power, pwede natin siyang ilabas.
Dito sa power rule, i-approach din natin dito, ilalagay din or i-apply natin yung theorem number 2 na which is yung x approaches to 2 yung magiging sagot. 2 to the third power. So, 2 times 2 times 2 times 2 equal to 8.
Hi guys, my name is Ashley Janela Cruz and I will gonna teach you how to theorem of limits. Let's go!
Number 1 rule, limit of constant. Limits of constant or x approach to a is equal to constant. For example, limit of 4 or x approach to 2 is equal to 4. Limit of 2 thirds and x approach to 3 equal of 2 thirds. Limit of negative 5 approach to 3 is equal to negative 5. And limit 4 over 5 is approach to 2 equals to 4 over 5. And that's all guys. Theorem of limit of function.
That's all guys, thank you for watching. Bye-bye.
Sa bidyong ito, i-explain ko sa inyo ang theorem and limits. Theorem 1. The limit of the sum of two functions is equal to the sum of the limits. This theorem may be extended to include any number of functions, such as find the limit of theorem 2, the limit of constant c times as function f of x is equal to the constant c times the limit of the function. Examples of using the central limit of the theorem in real life. The central limit theorem states that if we take repeated random samples from a population and calculate the mean value of each sample, then the distribution of the sample means will be approximately normally distributed even if the population the samples came from is not normal. The central limit theorem also states that the mean of sampling distribution will be equal to the mean of the population distribution. The central Limit theorems is useful because it allows us to use as a sample mean to draw conclusions about the larger population mean. 1. Economics. Economics often use the central limit theorem when using sample data to draw a conclusion about the population. For example, an economist may collect a simple random of 50 individuals in a town and use the average annual income of the individuals in the sample to estimate the average annual income of the individuals in the entire town. If the economists find that the average annual income of the individuals in the sample is 58,000, then her best guess for the true average annual income of the individuals in the entire town will be 58,000. Another example, surveys. Human Resources Department often use the central limit theorem when using surveys to draw conclusions about overall employee satisfaction at companies. For example, the HR department of some company may randomly select 50 employees to take a survey that assess their overall satisfaction on a scale of 1 to 10. If it's found the average satisfaction among employees in the survey is 8.5, then the best guess for the average satisfaction rating of all employees at the company is also 8.5. And next, I will be showing you the limit laws in my screen. Lamang mga may explain ko sa theorem and limit. Sana may nakuha kayo kahit konting kaalaman sa theorem and limits at paano ito magagamit in real life. Theorem 1. To make it easy for you to understand, if our C is a constant, then it will be your answer. Now let's have our theorem number 2. For any number a, the limit of x as x approaches a, that is equal to a.